Before I start or say anything, some information could be slightly wrong. I've done my best to prune this bit by bit and refine it to its best, but even for me, some concepts are a little confusing, which is why I highly recommend outright reading the sources I used to make this. They all contain a vast wealth of knowledge and information on the subjects at hand, and as long as you're willing to actually read them and or manually translate them, you'll most likely find more satisfaction and gratitude. But my goal with this is to have an easy platform to show and tell the information of the system to any person, be it a hobbyist or someone who's just interested. I hope you like this forum presentation and enjoy it. The predominant frontline fighters of the Soviet Union's Air Force, known as the VVS, during the early 1950s to late 1960s were the MiG-17, MiG-19, and MiG-21 aircraft. There were others, of course, but as a superficial statement, those will do. The main common component to these aircraft is that they could be on standby and used to fight any aggressors to the Soviet Union's airspace, but they were limited in compatibility and weaponry, range from the air base, all-weather fighting capabilities, and most importantly, couldn't find targets as easily, which had to be relied on by the pilot looking around. To also be kept in mind, during this point in the Soviet Union Air Force aviation defense strategy was the use of aircraft to intercept bombers and aircraft capable of using nuclear weapons, as that was the main big fear of the time before greater weapons of destruction were made and put into service, such as the ICBM missile. The task of interception itself will lead to the creation of the PVO, less commonly known as the Soviet Air Defense Forces. The PVO would see predominant aircraft of Soviet aviation design and use by the VVS, like the MiG-17s, MiG-19s, and MiG-21s, but not see them being capable enough to perform interception missions during the late 50s to mid-60s, due to them fully relying on GCI coordination and only being able to be best used in daytime operations. The PVO would be primarily responsible for demanding and acquiring aircraft with portable radar stations for interception missions, alongside special equipment to aid in their interception tasks, thus creating aircraft with the P suffix, indicating interceptor. These aircraft would range all the way from the MiG-15P to MiG-25P, ending after the MiG-25 saga of planes as further generations of aircraft were made to be compatible for both branches rather than being separate, leading them to lose the P suffix within their name. Aircraft with the P suffix in their name under Soviet aviation would be used primarily for only the PVO and for interception missions. The RP-21's use with the PVO and VVS is almost identical when talking about specific airframes, but it's the application and how they were used is what changes. Within the PVO, MiG-21PFs and MiG-21PFMs were used strictly for interception missions, nothing more, nothing less, as other AWACS-capable aircraft existed for monitoring airspace, alongside ground-based radars like GCI. The PVO's branch's second capability was the use and defense of Soviet skies with surface-to-air guided missile systems, which is why their purpose made interceptor variant aircraft only saw interception missions as they were not needed for any other purpose. Within the VVS, however, MiG-21s operating the RP-21 radar were used for any kind of mission that required it, such as patrolling a border, escorting other aircraft, CAP, and searching the airspace for foreign targets. Of course, there are still many more uses. VVS aircraft would not see use as interceptors and would often not be affiliated with missions of the such, unless it was in a foreign airspace like Afghanistan or any other country the Soviet Union participated in battle with. Starting the radar station. To begin, the radar has to be turned on to a warm-up status. The pilot must first put the right 3-position switch on the TSD-41U radar control panel into the high voltage setting, which is in the middle position. This will then begin the warm-up process for the radar. If a pilot is currently deployed in an aircraft that uses the RP-21MA, such as the MiG-21MF, the TSD-41U is instead replaced by the TSD-41A, which is a longer rectangular block above the radar display screen that has the same switches and labels as the TSD-41U. After 2.5 to 5 minutes passes, a set of relays will then allow the radar to then be put into the extreme voltage setting through the same 3-position switch. This will then turn on the radar and make it operational in flight. Low-level radar use. If the RP-21 radar station is used between 1,000 to 4,000 meters, it may be required to use the dimming terrain masking setting, controlled from the TSD-41U radar control panel, which is located on the left 3-position switch and the up position labeled as interference. To be also noted, the radar can be used as high as 100 meters off the ground after takeoff, but terrain masking will be a very prevalent problem until you reach 600 meters in altitude. This will make the terrain the radar picks up less substantial to the pilot via the radar display screen, but it is advised not to use the radar below 600 to 800 meters as the radar will only be able to pick up the terrain and is useless in any application in such a state. Fixed beam operation. If the pilot is equipped with the RS-2US, product name K5M, radar beam guided missile, the pilot will then have to put the radar station in fixed beam mode, which is located on the radar control panel within the left 3-position switch in the bottom position. The fixed beam setting will then make the radar station stationary and no longer move. Once the missile is fired, the missile will go wherever the radar beam is pointing, being manually guided by the pilot. Radar display screen use in Symbology. The radar display screen displays information gathered by the radar station and presented to the pilot through this display screen, or its more technical name, oscilloscope. Understanding the radar display screen is fairly simple and easy to understand. There's a little difference between radar display screens, but the one used in this demonstration is based off of the RP-21M/MA version, which was a modernized upgrade of the RP-21. The only differences between the two radars was that the RP-21 could only have a max range of 20 kilometers, whereas the RP-21M/MA could have a max range of 30 kilometers. Understanding observation mode. While the radar is on at any given time, it is in the observing mode. This mode will just display targets, weather accumulation, ground interference, and radar jamming. To determine height advantages and disadvantages when comparing the pilot's aircraft to the target's height and altitude, the radar display screen will have 3 ways of displaying how the target is either above, below, or at the same altitude as the pilot. If the target is above the pilot, otherwise told as being located in the upper sector, the display screen will show a horizontal line with 3 vertical lines above it to denote the target's height above the pilot. If the target is on a similar altitude to the pilot, told as being as the middle sector, the display screen will show the horizontal bar with 3 vertical lines at the top and bottom. If the target is below the pilot, the target would be located in the lower sector on the display screen, which will show a horizontal line with 3 vertical lines underneath of it, to denote this fact. Since the observing mode is the default mode for when the radar station is being used, the display screen will also pick up weather accumulation and ground interference, also known as terrain masking, thus blocking the pilot from seeing potential enemy aircraft. This can be remedied with the left 3-position switch on the TSD-41U and TSD-41A to limit its hindrance to the pilot, but it will still be present on the radar display screen. When determining a target's originating country, the aircraft is to be installed with the Silicon II SRZO2 IFF system to determine nationality of foreign aircraft. Once the interrogation button is pressed in the cockpit, all targets showing on the radar display screen will show either a equal sign or a minus sign. If the target shows an equal sign, then it is a friendly aircraft. If the target shows a minus sign, then the target is a potential hostile enemy or unknown foreign object. Understanding ranging. The vertical plane within the radar display screen represents how close or far away the target is from the pilot's aircraft. If the target is further to the top of the display screen, then that represents the target being further away from the pilot. As the pilot gets closer to the target, though, the target will move downwards. If a target is at the top of the display screen, then the target is 30 kilometers away. Equally, if a target is all the way at the very bottom of the radar display screen, it is 5 kilometers away from the pilot. The radar display screen can also instruct the pilot if the enemy aircraft is to the left or right from the pilot's aircraft. This is instructed by the top of the display screen having 4 hash marks, including 2 15-degree numbers. In the display, the outer 2 hash marks represent 30 degrees. Each dot in the middle of the radar display screen represents an amount of distance. The furthest high dot represents 30 kilometers. The next 2 dots represent 10 less kilometers from the last, so it would go 20 kilometers, then 10 kilometers. The final dot, though, would represent 5 kilometers. The other 4 hash marks within the middle of the radar display screen represent the target to the left or right, by varying increments of 5 to 10 degrees. Understanding target tracking / interception. Once an enemy target is located, the pilot will then have to maneuver the aircraft to get closer to the target and make sure it is lined up in the middle of the radar display screen. The circle in the long rectangle underneath it, in the middle of the screen, represents the zone in which an aircraft can be locked onto by the radar after hitting the lock-on button. This is done by hitting a certain button on the joystick. Once a target is locked onto, the radar station goes into the automatic tracking mode. Once in this mode, the target, and any other ones, will then disappear and new symbology will appear. A small line will then appear in the center of the display screen with a vertical line sticking up from the middle of it. This represents the aircraft that is currently being tracked. There will then be two open gaps, or spaces, within this line, and then it will go back to longer lines. If the hostile aircraft moves while this process is happening, the symbology will move with it to show the pilot of its target's movement. The space that has no continuation of a line represents the optimal missile launch zone, that being 6 kilometers. The rest of the line represents the distance from the pilot's aircraft to the target aircraft. To indicate to the pilot as he gets closer or farther away from the target, two vertical lines will be on either end of the long horizontal lines. This indicates to the pilot how far away he is from the target. As the pilot gets closer to the aircraft, so too will the vertical lines. Once the vertical lines enter the open space, the aircraft will then allow permission to fire missile systems against the target. A light will also turn on the radar display screen that will instruct to the pilot he has permission to fire and is in optimal range. If the pilot gets too close to the target, a 0 light will turn on. This will communicate to the pilot to break off from the attack immediately and go back and try again. While on this tangent, if a P light appears on the radar display screen, that means the low altitude switch is on and is allowing the radar to function at altitudes of 100 to 3,000 meters. RP-22S, SMA Radar Operation. Understanding the differences between the RP-21 and RP-22 radar stations. The RP-21, M, and MA work very similar to the RP-22, SMA. The radar stations in operation within space and with the pilot. The only real differences between the RP-21 and the RP-22 radar stations was the ability to use radar-guided missiles with the RP-22, specifically the R3R, or product name K-13R missile, and radar symbology were changed to be more easily digested by the pilots for understanding, and to give more information. Alongside more information, the RP-22 was given the ability to have extra settings the pilot could operate in for different tasks and conditions, more specifically radar-resistant jamming modes. This also made the radar settings easier to control through a new interface for these new and old modes of operation, labeled as the Block 19A. Understanding the new symbology. Learning the new symbology. Much of the symbology of the radar display screen is very similar to the RP-21's radar display screen, but slightly changed to be made easier for pilots. At the very top of the display, it shows 30. This represents the radar's max detection range in azimuth, that being 30 kilometers. From then on, it goes to 20 and then 10, each representing kilometers of detection range. So, if the target is 25 kilometers away from the pilot's aircraft, then the aircraft will be shown in between the 30 kilometer and 20 kilometer range marks. In the middle of the radar display screen, the small vertical bars next to the lock-on area represent if the target is to the right or left of the pilot by 5 to 10 degrees. The lock-on area, which is in the middle of the radar display screen that looks like a rectangle with a circle, inside that circle is a plus as well, and two horizontal bars that are spaced from each other. At the very bottom of the radar display screen are 4 triangles. These triangles represent azimuth markers. Just like the RP-21, whenever a target is present on the radar display screen, it will also show its relative height compared to the pilot's aircraft, that being above or below the pilot. Just like the RP-21, if an aircraft is above the pilot, also known as being in the upper sector, the radar display will show a horizontal line with one vertical line sticking up from the middle of it. For the target, instead, if a target is below the pilot, also known as being in the lower sector as well, it will show a horizontal line, but the vertical line will be to the bottom. If the target is on the same level as the pilot, the radar display screen will show a combination of the upper and lower sector target displays. The combined image will be very similar to the RP-21's and show a line above and below with a horizontal line in the middle. It is imperative that before attacking or locking onto a target, the pilot must confirm if it is an allied or hostile aircraft. By using the Zapros button in the aircraft, it will initiate radar interrogation of the targets using the Silicon-2 SRZ02 unit. If the target shows a equal symbol, it is friendly. On the other end, if it shows a minus symbol, it is hostile, just like the RP-21. The long rectangle represents the range and position the radar can lock onto an aircraft in, which its max lock-on range is 17 kilometers. Throughout the rectangle, there are two sets of extruding lines in varying positions. These lines are meant to denote distance from the pilot and to the aircraft as well. The top set represents 13 or 14 kilometers, and the bottom set represents 7 kilometers. The very bottom of the rectangle should indicate to the pilot 15 kilometers, aka too close. The circle with a plus within it represents the very center of the display. The two long horizontal bars that almost go from one side to another in the rectangle in the horizontal position is the target marker. You use the target marker to line up a target in the rectangle, and then you turn the thrust handle to move the target marker bars up and down within the radar display screen. Once the target marker is over the target, the pilot can then lock onto the enemy target by hitting a button in the joystick. At the very top of the radar display, on the frame of the display, are three symbols: left arrow, straight line, right arrow. These symbols are used when being paired with the laser system. The laser system was a form of communication from the GCI controllers to help guide the pilot's aircraft into an oncoming target. Updates from laser are presented through these symbols, which will light up when the pilot needs to correct the plane's direction it's going in. The left arrow informs the pilot to move more left, the right arrow informs the pilot to move more right, and the middle line informs the pilot that they are on the correct course to the target. Each line that is at an angle also represents where the target is based in those directions. So the top right angled line represents that the target is to the right by at least or more than 45 degrees. Though do note, these lights are only on the RP-22 SMA and not the RP-22 SM. For laser guidance. The text that is then presented on the display frame will be displayed with lights when that operation is being executed by the pilot. The bottom two words represent whether the low altitude interference mode is on and when the radar experiences a failure. When the radar station experiences a failure, it will then turn on that light, which will tell the pilot to turn off the radar station to protect it. The remaining text on the left side refers to when the radar guided missiles have achieved lock-on and when to fire the missiles. The RR denotes if radar-guided missiles have gone a lock-on to the target and tells the pilot they are being actively used. The other word tells the pilot when they have launch authority to fire a missile for a probable hit, which appears in the target tracking mode when the two vertical bars reach the spaced out line portion from the target. The zero near the top right of the frame will turn on when the pilot's aircraft is too close to the target, instructing the pilot to break off immediately and try again. Understanding the new radar controller unit. The old TSD-41U and Block 19 share many commonalities between the two systems and how to start and operate the radar station. Such options are to enable low altitude interference, enable an extra low altitude interference mode that moves the radar antenna 1.5 degrees upwards for better visibility, and to enable fixed beam mode, as well as have the radar off, warming up, and fully turned on. The main difference between the TSD-41U, TSD-41A, and Block 19 is that multiple lights are present to inform the pilot when the mode of operation is being used, and the different forms of construction between all three variations of system correspondence. Understanding the new radar modes. The new modes of function of the radar are presented through the Block 19A, also known as the RP-22 radar control panel. Each button has a built-in light that will glow upon pushing it to communicate to the pilot that mode is currently on and operational. The top row of buttons, NEPR, PRER, and PASS, are designed as active and passive interference protection modes to ensure radar functionality during certain scenarios, such as jamming from hostile radar systems. These modes will limit their jamming ability, while METO on the top row is for radar interruptions from atmospheric conditions, more specifically, when clouds are present containing rain within them, causing the radar beams to bounce back early and cause a massive projections on the radar display screen. The very left button on the second row is called Request, and once pushed will activate the interrogation system for recognition of ally or foe targets using the Silicon-2 SRZ02 IFF system. This button is often referred to as Zapros. To the right of the last button presented, the MSC button will disengage the selection system and allow for targeting and attacking of slow-moving targets, such as helicopters. The next button is labeled as Control. Once this button is pressed, the radar system will automatically go into testing mode to ensure radar operability. The last button on the bottom row is labeled as Reset. As its name implies, once pushed and activated, all other modes will be set off and the radar will be returned to its normal operating position. Missile pairing. Each evolution of the radar station could be paired with special blocks that would allow the radar and the simplified memory system within the aircraft to see, recognize, authorize, and use certain air-to-air missiles on the aircraft. However, these blocks were only made compatible with certain versions of radar stations. The standard non-modified RP-21, TSD-30TP, or TSD-30TPM radar station could accept the R3S, known as its product name K-13A, and RS-2US, known as its product name K-5M missiles. The latter would be used in tandem with the locked-on beam mode, selected via the TSD-41U or TSD-41A. Whereas the R3S would be used in tandem with the standard tracking mode automatically done by the RP-21 itself after exiting observation mode. These same missiles would stay and be present on the other RP-21 radar stations, even the RP-22. The RP-21M, also known as the TSD-30TK, would potentially be given the ability to use the R-13M, product name K-13M, missile system. But it was definitely confirmed for the RP-21MA, also known as the TSD-30A missile, to use the R-13M missile. And much later on, the RP-21MA would be retrofitted for use with the R-60/R-60M missile, but only to certain customers, of course. Certain customers being more specifically the Czechoslovakian Air Force. The second generation of radar given to the MiG-21 airframe, designated as the RP-22S, Sapphire 21S, would be given the new ability to use radar-guided missiles, designated as the R3R, product name K-13R, which were SAR, semi-active radar homing missiles. The R3S and R13M would also be usable with this radar station. Later, with the creation of the RP-22SM, the R3R, R3S, R13M, R13M1, and later the R60/M would be usable with this radar station as well. Lastly, the RP-22 SMA Radar Station would be able to use the R3R, R3S, R13M, R13M1, R60/M, and the R55 missiles. The R55 missile was made as an export missile based off the RS-2US with a replaced guidance system, that being infrared guided. Sight pairing. The MiG-21PF and MiG-21PFM saw the removal of the main display sight for its weapons compared to the previous generation, that being the MiG-21F13 with the ASP-5ND. The sight is important for bombs and rockets all the way to the missiles. This new interceptor variant, that being the PFs and PFMs, would instead have a simple collimator PKT sight in the radar display oscilloscope, Block 34, replacing the old designated ASP-5ND sight location. When the MiG-21M and MiG-21MF were designed and being put into serial production, they were reinstated to have a more universal role rather than just being made for interception missions. Thus, they had to be given a new main display sight for the air-to-air and air-to-ground attacking modes, that being the ASP-PF21. Which was tailor-made to be compatible with the RP-21MA radar station system for proper cooperation. The scale on the ASP-PF21 will move according to the target's distance compared to the pilot's, that being a 0 to 2 km scale and a 0 to 9 km scale for use with the radar. When the MiG-21S, MiG-21SM, and MiG-21Bis were designed and made operational, they were given the new RP-22S, RP-22SM, and RP-22 SMA radar stations. To be made operable with the radar station, a new sight would be made to facilitate these new radar stations, being labeled as the ASP-PFD21. This sight would include an additional scale for closer ranges when comparing the target's position to the pilot's, that being an extra 0 to 2 km scale and a 0 to 9 km scale for use with the radar station. Radar functionality. Precursor, RP-9U, TSD-30T. The first and early versions of the RP-21 were fitted to the Su-9 interceptor series of aircraft. Since these were early versions of the RP-21, they were labeled as the RP-9U, or TSD-30T. Very early MiG-21 PFs got these radar stations as well, but only after the first roughly 200 units they would then start to receive the RP-21, and any previous aircraft equipped with the RP-9U would be upgraded to the RP-21 standard. RP-21, TSD-30TP or TPM. Radar performance. Radar observation detection ranges. Maximum detection range 20 kilometers. The radar range in azimuth is plus or minus 30 degrees. The radar angle of inclination, side views, range is plus or minus 12 degrees. Each portion of space the radar sees and interacts with is 1.9 seconds long. Target tracking zone in azimuth 30 degrees. Target tracking zones plus or minus 17 degrees in angle of inclination. Automatic tracking error on regularities is no more than 0.15 degrees. Target detection zone of no less than 20 degrees in azimuth. Station operation time is ready within 3 to 5 minutes. Permissible changes of lateral tilt of the aircraft while the radar display does not change in azimuth is 70 degrees. Once passed, the radar will lose the lock-on of the target. Permissible tilt of aircraft after firing a missile is plus or minus 30 degrees. The target interception zone is 1.2 to 0.3 kilometers and 13.5 to 2.0 kilometers. Sensitivity of interference. Non-synchronous pulse disturbances with frequency of 25,000 IMPs per second distance detection and auto-target tracking is not affected. Non-synchronous pulse disturbances with a frequency of 25,000 IMP a second to 50,000 IMP a second will decrease detection and auto-target tracking by 15 to 20%. With active interference in the range of 80 dBm to 20 dBm, the station will provide guidance to the target's source of interference but will not provide any information about the target's current distance to the pilot's aircraft. Aircraft detected from rear hemisphere based on size. Tu-16, 17 to 19 kilometers, most likely above or at 6,000 meters. IL-28, 14 to 17 kilometers, most likely above or at 6,000 meters. Missile approach conditions. Dangerous approach distances for the R-3S and RS-2 U.S. missiles on target is greater than 14 kilometers, minus 1.95 plus or minus 0.2 kilometers. Dangerous approach distances for R-3S and RS-2 U.S. missiles on pilots' aircraft are less than 14 kilometers, minus 1.35 plus or minus 0.2 kilometers. RP-21M TSD-30TK. Radar performance. Radar observation detection ranges. Maximum detection range is 30 kilometers. The radar range in azimuth is plus or minus 30 degrees. The radar range of inclination is plus or minus 12 degrees. Each portion of space the radar sees and interacts with is 1.8 to 2 seconds. Target detection zone is 30 to 31 degrees. Target detection zone of no less than 20 degrees. Automatic target tracking zones plus or minus 29 degrees in azimuth and plus or minus 70 degrees in angle of inclination. Station operation time is ready within 3 to 4 or 5 minutes depending on conditions. Permissible changes in tilt of the aircraft while observing in azimuth 70 degrees. Permissible tilt of aircraft after firing a missile plus or minus 30 degrees. Target interception zone is 1.2 to 0.3 kilometers to 13.5 to 2.0 kilometers. RP-21MA TSD-30A. The RP-21MA TSD-30A is identical to the RP-21M except for receiving a new designation, that being the additional A, due to the installation of the ASP PF-21 sight, TSD-41A control panel, and the receiving of new weapons. No characteristics have been changed to my knowledge, as a few manuals lump both radar stations together. RP-22S SATFR-21S. There is little to no information present about this radar station, but it would be most likely comparable to the RP-21. RP-22 SM, SATFR-21 SM. Radar observation detection ranges. The radar range in azimuth is plus or minus 30 degrees. The radar angle of inclination range is plus or minus 17 degrees with a potential plus of 0.5 degrees. Each portion of space the radar sees and interacts with is 1.8 to 2 seconds. Target detection zone is 30 to 31 degrees. Target detection zone of no less than 20 degrees. Automatic target tracking zone is plus or minus 29 degrees in azimuth and plus or minus 17 angle of inclination. Station operation time is ready in 3 to 5 minutes. Permissible changes in tilt of the aircraft while observing in azimuth 70 degrees. Permissible tilt of aircraft after firing a missile, plus or minus 30 degrees. Target interception zone 1.2 to 0.3 kilometers to 13.5 to 2.0 kilometers, and it has a dead zone of 500 meters. Aircraft detection by radar station. Bomber-sized aircraft can be seen from 23 to 27 kilometers away at 8,000 to 10,000 meters in the air. If said bomber aircraft is instead at 500 to 1,000 meters in the air, then the radar station can get a potential detection of the aircraft around 11 to 20 kilometers away. Fighter-sized aircraft can be seen from 17 to 23 kilometers away at 8,000 to 10,000 meters in the air. If said aircraft is instead at 500 to 1,000 meters in the air, then the aircraft radar station can get a potential detection of the aircraft around 8 to 11 kilometers away. RP-22 SMA, SAFR-21 SMA. The RP-22 SMA is nearly identical to the RP-22 SM in function and combat ability, but includes extra features in the radar display screen and frame for the laser system, and having text that appears when certain operations are performed, but it appears there is no change in radar station ability. Evolution with main service MiG-21 airframes. MiG-21 PF/PFM, roughly from 1961/1964. The early units of the MiG-21 PF would originally receive the RP-90 radar station and would be eventually updated to the RP-21 standard when that unit went into mass production. The same can be said when the RP-21M radar station went into service. The MiG-21 PF began being upgraded to the new standard. The MiG-21 PFM would have been equipped with the RP-21 or possibly RP-21 for export models when the airframe went into service. By 1964, the MiG-21S would enter service with the ability to use the R3R radar-guided missile. MiG-21M/MF, roughly from 1968 to 1970. The MiG-21M and MF would originally receive the RP-21MA radar station, which had a new way of controlling the radar station with a re-engineered control panel which did the exact same functions. Like the rest of the plane's cockpit, many items and pieces would be re-engineered and reorganized for the MiG-21M and MF. That also included its weapons suite. However, the Czechoslovakian Air Force, at the time of course, had MiG-21MFs that were upgraded to use the RP-22S or RP-22SM radar station compared to other nations. MiG-21S/SM, 1964/1969. The MiG-21S and SM would respectively receive the RP-22S for the MiG-21S and the RP-22SM for the MiG-21SM. Of course, these would be some of the earliest radar stations made to use radar-guided missiles for the MiG-21 airframe, which were known as the R3R, being a semi-active radar homing SAR missile. These forms of MiG-21s wouldn't see any exportation out of the Soviet Union until enough time had passed and was deemed by the state that the radar station only would be made to be exportable, which began and ended with the MiG-21Bis. MiG-21Bis, roughly 1972. The MiG-21Bis would be equipped with the RP-22SM or RP-22SMA. The RP-22SMA would be able to work with the laser system more efficiently and communicate more information to the pilot when certain modes are being operated. The Soviet Union VVS and PVO used the MiG-21Bis, but by this point in time, which was around 1972, there were better aircraft being fielded for the occasion that the MiG-21Bis filled. Some examples for these aircraft being the MiG-23 and Su-15, which led to many nations being allowed to purchase the MiG-21Bis, some countries being Poland, Yugoslavia, and East Germany. Of course, there were other countries, but those were the main operators of the MiG-21Bis. TSD-41U, 41A, and Block 19 detailed look in comparison. The TSD-41U, TSD-41A, and Block 19 all perform the same function within the radar station, that is, to power the station, enact low-altitude modes for better use of radar, and the enabling of a fixed beam mode. The only change from one unit to another is the unit's case construction and the positioning of lights and switches. The TSD-41U was the original radar station controller and, as such, is much more simplified and compact compared to the others. This was because the TSD-41U would be mounted higher up in the MiG-21 PFs and PFMs cockpit. The next generation upgrade was the TSD-41A. This was designed and made to be easier for the pilot to understand, and more importantly was made to fill in the new radar display gap slot that was present when the RP-21MA radar display screen was moved to the lower right corner of the central cockpit panel. The Block 19 would again be moved to the small right-angled panel within the MiG-21Bis. The old gap space would then be reused for the second radar controller known as the Block 19A, which would provide more functions compared to the other two generations of the radar controller. Information pertaining to other blocks. The RP-21M radar station installed on the MiG-21 airframes consisted of the following blocks: TSD-31TK, Commuter Antenna Equivalent, Block 29, Synchronization and Protection, Block 25, Transceiver, Block 32, Receiver, Block 33, Code Formation and Marker, Block 36, Grid Stabilization, Block 39, Distance, Block 37, Antenna Control, Block 40, Magnetic Amplifiers and Stabilization of Antenna, Till, Block 44, Time-Based, Block 46, Pointer, Block 34, Signal to Noise, Block 26, Power Supply, Block 38, Control Panel, Block 41U, Control Panel 41K, Non-Wall Box, Block 41, BSJU Sync Block, POW Photo Capture of Radar Display Screen, and Ground Control of Station Panel, Block 48.